We finished the first day, 7 days. So let's dig into the 8th. Quest 8, a shrine for a null pointer. All right. Part 1. As you well know, the Knights of the Order of the Golden Duck are also exceptional architects. I didn't know that. The next challenge pertains to their architectural skills. The priests wish to erect a new shrine in honor of the god Null Pointer, the protector of the lost. They are certain that the structure must be symmetrical with precisely one highest point, but they cannot decide on the material and the exact shape. The first proposal is a pyramid-shaped structure made of stone blocks. From the highest point of such structure, the height decreases by 1 block down for every block to the side. Yeah, I'm looking at the pyramid here. The algorithm for planning such a shrine is as follows. Place 1 block at the location where the center of the structure will be, ensuring the shrine will always has a single highest point. Determine the thickness of the subsequent layer. For a pyramid, the thickness of all layers will always be 1. Begin adding a new layer by placing blocks on the ground to the right and left. Add new blocks to all columns that existed in the previous layer. Continue adding subsequent layers following the same principles. An example construction plan with layered blocks marked by numbers could look like this. The first layer contains a single block of 1 stone. Second contains 3 blocks. Third is made of 5. For the fourth, 7 are needed. The number of blocks for such structure is limited, but there's precept a considerable quantity at their disposal. Your notes. The king has also agreed to order an additional number of blocks to ensure that all layers are completed and the structure is perfectly symmetrical. The knights wonder how wide in number of blocks the final structure will be and how many additional blocks they must order to achieve a fully symmetrical shrine. For example, based on the following notes, 13. Your note is a single number. Available number of blocks, 13. Okay. With that many blocks, the following shrine can be built. To complete the final layer, an additional 3 blocks must be ordered with a marked with $sign below. The final structure width is 7 blocks. Your final answer is the product of multiplying the number of missing blocks by the target width. 3 times 7 is 21. Determine the final width of the shrine and the number of additional blocks needed to complete the final layer. What is the result of multiplying the number of missing blocks by the target width? Okay. So how does this work? We have 1 block per 1. We add 3. We add 5. We add 7. So the next one we would add 9, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's just squares, right? We have 1, 4, 9, 16. So if we have 13 blocks, we know that we can build a structure with 9, and then we know that the next higher up one is going to be 16. So this doesn't need any programming. This is just straight math, right? We know 16, and then we have 16 minus 13 gives us the 3. And then we have to multiply by the width, which is, in this case, is 7. And that's just the final square root plus that value minus 1, right? Because there's 7 blocks here. So we have 4. 4 plus 3 is 7. Here it's 3. 3 plus 2 is 5. 2 plus 1. And this is just 1 plus 0. Okay. Can we solve this just with math? Let's first see, let's grab our download. Let's create our new solution, cargo new. Day 8. Bacon Clippy. Source main. Let's take a look at our downloads, everybody codes. Got input, everybody codes. All right, so we have this number here, 4098001. If I square root that, right, let's just pull up the calculator. There's a scientific. There we go. If I pull up the calculator and put this number in it, 5097, 4098. Come on, 498001. And I hit square root on that guy. Equals. 2024. So it's between 2024 and 2025. That's how big the pyramid is. This is how many blocks we have. If I say 2025 minus squared minus 409, oops, I did it again, 498001. That's how many blocks we need, 2624. And now I need to multiply that by the width, which is going to be 2025. So multiply that by 2025 plus 2024. Right? If I said copy on that and paste it into the answer, is that all we need? I quacked it like a pro. All right, let's see if we can do it with a program. And see if we can come up with this number here. So we need to read in the file. The file is just that single number. Yeah, 4098001. Okay. So we can say AOC lib read lines of input slash everybody codes. Like that. And our line 0. So let blocks is equal to lines of 0. Let's just do it like this. U64 bars unwrap. I'm just going to print it out, blocks, right? Oh, it doesn't like that. Oh, because I forgot to say line like that. Oh, I forgot. I have to add the dependency. What is it? It's like workspace dot. I always forget this. AOC lib workspace equals true. Okay. No alternate file. Oh, okay. Yeah. Okay. There we go. Run. So that's how many blocks we have. We want to take the square root of it, which you can only do in F64. So we can say println square root is equal to this. So blocks as F64 squirt, right? And then we want to take the floor of that. So we can call it the previous level. Previous pyramid is equal to blocks as F64 dot square root as U64. And then we can say previous is equal to pre-pyramid. That? Yep. And now we just need to add 1 and do the difference, right? So it's basically, let's say the next or final pyramid is equal to just pyramid plus 1. You don't need to print out the blocks. And then we just need to say the difference is equal to final pyramid times final pyramid minus the blocks we have. And then we can say println part 1 is equal to, it's going to be the difference plus final, difference times final plus brief. And it should give us the same number as the one we calculated. It did. Okay, so that was easy enough. That's part 1. I can't imagine there's any issues with Clippy in that. Yeah, that was a less than programmatic. Oops, because I have multiple mains here, or multiple Vim sessions here. Get status. Add cargo lock. And that. Right, get commit, get log. Let's use the same format. Get commit -m quest 8. All right, that was easy enough. I cracked it out of the park. It took me 5 minutes. It took me 6 minutes to read and solve the problem, non-programmatically. I'm not sure how long it took me to do it with a little software. All right, part 1 done. Let's check our progress here. Where's the 8th wheel? Oh, it's over there. And we must be working our way up to the green thing then. Okay.